All right, we have one more formula that we want to look at, and that is the binomial probability distribution. Okay. Ooh, one of them. So this one's a complex formula, and I want you to focus on this because you are going to make your own example, like this example. Do you all know Shampria? Who knows Shampria? Do you know her? You guys don't know her? She was in my class last semester. I thought maybe you did. Basketball player.
Oh, she's short.
She's a little bit short. Yeah. Okay, now do you know her? Okay. Well, this problem's about Shampria. Okay. And you're going to make your own problem that's something like Shampria's problem. Okay, something like, I don't want change the name and change the percents and call it good. That's not what I want. But that's going to be the basis for your presentation for this unit. So just so that you know, this is something you should really focus on and make sure you understand. Okay, so here we are, probability distribution formula. It is the probability of X successful events. I said the word probability. Am I going to have a percent or a decimal for that? X should be in a decimal. Because it says probability, so I should expect it to be a decimal. From N trials. N trials means N attempts. Like if you're standing there shooting baskets like Shampria is, she stood there for, what did we have her do? 14 attempts. Those are 14 trials. It's the same thing. Okay? You might also see attempts. Or you might see something more appropriate to your actual problem. Okay, where P is the probability of success, what kind of number do we expect? Decimal or a percent? A decimal? Because? How do you know decimal? It's a probability. Very good. So P is the probability of success, and Q is the probability of failure. What do we expect Q to be? Percent or decimal? Decimal. And for Shampria's example, you're saying 0.3?
Yeah, if it's the probability.
And how'd you find that?
Subtracted 1 minus 0.7.
1 minus 0.7 for Shampria's problem, right? Okay. So we're looking at what, if you know the probability of success, it's called binomial because there's two outcomes. Like bicycle, biannual, all that, it means two. Binomial, it means there's two outcomes, success or failure. That's all you can measure for this one. If you have something where you're ending up with 5 different colors or something like that, it won't work. It has to be for this formula. It has to be something that has success and it has failure. And that's it. There's no gray areas. So either yes or no, success or fail, true or false. Any of those you could use this formula to help you with. That's what the binomial part means. There's only 2 answers, right or wrong, right? Okay, so we have this P of X. This is notation. It's function notation. You might have seen it in other classes. We have not really looked at it in this class, but I want to talk to you about it just a little bit. But it's saying this big P, that's the name of my function. And then this X is the value I'm going to plug into my function. That's the left-hand side. That will stay the same all the way through your problem, all the way onto your answer. So when you finally figure out what your X is, then it's going to go in there instead of the X, and it'll say P of, say, 3. P of 3 equals, and your answer will also say P of 3 equals, and whatever you calculated on the right-hand side. Okay, so it's just notation. It's not instructions to multiply or anything like that. Just notation. So put whatever on your paper so that you know this part here, just notation. And that means it's not operations like add, subtract, multiply, etc.
Is that x the same x that's under n?
It is the same x that's on the right-hand side in the x's there, and in fact, that's where you plug in the x's on the right-hand side.
And then are you dividing right there?
What does this mean? Let's look at the right-hand side now, because Tori's moved on to that. It's okay. It's okay. I was talking about the left-hand side, but let's look at the right-hand side now, because that's the next thing we need to talk about. This thing here, has anyone seen that before? It definitely is. How do you say it? Do you remember?
N choose X.
N choose X. And here we have little n, but it's the exact same thing. N choose X. And that is definitely from combinations that we did before. Remember that? How you do it on your calculator? Can someone tell me the button name? NCR, N choose R. This one's N choose X, but the same thing, put whatever your X is instead of where they have R. Yeah, and that on your calculator, remember, you'll have N capital C and then little r, and you might have it in a menu. I'm hoping you remember how to find those. Okay, so that's giving you one thing. What about this next part here? How would I say that? P to the x or p to the power of x. Very good. P to the x. And do you remember where to find to the on your calculator? Y to the x you might have. What else? Some other people have a different button. Do you remember what it is? Why, that's right. You might have the little caret button. Okay. Okay, so those are your to the buttons. Now what's this last part? It's just another to the. And what is this one? How would we say this one? Q to the. And I'm going to put parentheses n minus x because that whole thing is my power there. Okay. Do you think we can manage this one? I think we can. Let's try it out. So what do we know? Because we have, look at all the variables that you have in that formula. We have x, we have n, and we have p, and we have q. Did I miss anything? I think that's it. Just 4. It's not as bad as it looked at first. What does x stand for in words? So look up on the original description of our formula. What does X stand for? Successful. Successful events. Okay, and what does N stand for?
Trials.
Number of trials. And what does P stand for? Just probability,
Success.
and this one's for success. And what does Q stand for?
Probability of failure.
Were we given the probability of failure for Shampria?
You have to find it yourself.
And how do you find it yourself?
1 minus the decimal 14%.
Q equals 1 minus P, which has to be in decimal. Do we know anything else? How about some numbers? Where do they go? Do we know? Okay, we'll need to use N choose R. Very good. And do we know X, what value we want to use for X? Can you tell from this problem? What will it be? 70%. That sounds like a likelihood. because you said percent on it. What else could a likelihood be? If we converted it to a decimal, it would be a, starts with a P, probability. So that sounds like a probability because it has a percent on it. Do you think so? This one's a little bit tough to figure out what goes where. That's why we're taking some time on it. So if we have a percent, that's her success rate. It says that's her success rate. 70% free throw success rate. So that means over games, several games that she's gone and played in, when you added up all her rates and divided by how many times you collected data, her rate was 70% success. All the tries, every time she tried to make a free throw, out of how many free throws she actually made. So it's actually the other way around. So the number of free throws she actually made over the number she tried in several games. And then you got 70%. So that's her rate, her average of how many times she makes a basket. So what we're trying to figure out is for Shampria, if she has 14 free throw tries, what's the probability that she's going to make 12 of them? Try on your calculator. What is 12 tries out of 14, or 12 successes out of 14 attempts?
86%.
That's 86%. What's her average?
70.
So it's way above her average that we're asking you to figure out what's the probability of her doing that. It's not going to be 70% because she makes 70% of her attempts. So what's the probability she'll have a game where she does super well, way better than her average? That's what we're asking here. Okay, so to do that we have to figure out where things are going to go. 70% we really think is a probability, right? Where might that go? For the P, and change it to a decimal. So 0.7. Does that make sense to you how Jermaine and I decided to put that down at P instead of up at X?
Yes.
Yes? Okay, because it's a probability, we can put it down there at P. What is the probability of failure for her then? I heard some of you saying it earlier. 0.3, and we get that by 1 minus 0.7, and so we get 0.3. That's the probability of her failing if we wanted to be negative about it and think, oh, she fails 30% of the time. Right? That's what we're saying. Okay. What else do we know now? N is 14, the number of times she's going to try or make an attempt. And that would make X the 12. Good. Okay, so that I would guess is going to be where the big challenge is. Once you've worked through this formula a couple of times, it's not going to be so difficult to calculate. But finding where the numbers go might give us some challenge. So let's work on this. 12 is our X, N is 14, P is 0.7, Q is 0.3. Let's try plugging that in. So we're going to say P of, what was my X? 12. So that tells me what is the probability that she will have 12 successes. That's the notation. That's what the notation means. Probability of 12 successes, and then I have to put in my NCR thing. So I have N is 14, and here in my formula it's going to be X, so 12, so 14 choose 12, okay, and then there was a times there that I kind of covered up with my blue lines. And what's next? 0.7 times what? To the power of? Okay, be careful on that because it'll be different on your calculator if you do multiply instead of to the. So 0.7 to the 12th. And then instead of this times dot, because it's going to mess up with my decimals, I'm going to just put it in parentheses like that. And put this one as multiply in parentheses as well. And what's my Q? 0.3 to the what?
Second part,
And how'd you get second?
the formula you gotta subtract 14 by 12.
14 minus 12. And generally we want to do that right away like Ty did, and you can just cross it off and put a 2. And don't scratch it out so I can't see what you did, but just one line so I can go, okay, we're replacing here with a 2. Okay, so now what? Work the parentheses. And the first thing that you might want to do, I'm going to tell you, whatever your largest decimal number is, which in this case is 0.7, that's going to give you the biggest number when you calculate it out. So save it for the very last, calculate the other ones and write them down or store them on your computer. So do y'all remember how to do n choose r? Can you come show me? I'll find it. It's on here. Oh, there's mine. Above the number 8 for this calculator, if this is the one you have. Otherwise, you might have to type the PRB button to get to the probability and then pick out the one that says NCR. Okay. So when I do 14 choose 12, what number do you get?
91.
91. Are y'all getting that? Yeah? Okay. And I'm going to leave this one because it has the largest decimal. So 0.7 to the 12th, I'm going to leave for a second. What do we get if we do 0.3 squared? .09. And actually, I think I told you backwards. We're looking at the exponents. Wherever the exponent's largest, do that one last. So I've written down these other two, and now I want to do the 0.7 to the 12th, and let's see if it really is a lot bigger and longer than the 0.09. So 0.7, y to the x button, or x to the y button, or your caret key to get your exponent, and the 12. Big old long number. Goes on. And then what am I doing with that? I can write down an approximation of it. And it would be 91 times, I'm just going to write down a little bit, 0.0138 ... because it goes on, times 0.09. So now I have that on my calculator still. Remember how to leave it on there, and then just do times 0.09 equals times 91. And it doesn't matter what order I multiply those in, but I should end up with P of 12, or probability of 12 successes, equals, what do you get? That's what I got. Did y'all get that too? Okay. What is that as a likelihood? What percent likely is she to make 12 out of 14 attempts? 11%. That's not very high, is it? But did it surprise us? Because remember, 12 out of 14 gave us what? 86%, which is way above her normal success rate. 12 divided by 14, and you get 0.86. Convert it to a percent, and it's 86%. Yeah. So just the rate of 12 out of 14 gives you way higher than her normal success rate, so we don't expect it to be really probable. But we can come up with, this is red, probability of 12 successes is 0.1134. Okay, so let's write that down. 0.004. And we could be even more specific, which I would really love you to do on your presentation. And we could state it in terms of Shampria. What would you say if you were reporting about Shampriya since you did all this calculation for her scenario? How would you report this? Go ahead, Aaron.
Shampriya's probability of 12 free throws and 14 attempts is 11%.
Okay, now go back and think about the word that you used in the problem, and does it match the form of your answer? It should be as a decimal because we said probability, right? So it should be what? Now, how would you change that if you wanted to report it as a percent? Okay, Shampriya is, I would say, 11.34% likely to make 12 out of 14 free throw attempts. Okay, so that's a hard part too. Phrasing your answer based on the problem itself. So that's why I'm taking so much time on this, because on the next page, it's basically plug and play. And that's to make sure you can actually do those calculations, but I also want you to be able to go from the wording of a problem, plug it into the formula, and then interpret your solution. Okay, so that's just as important. Are you guys okay on this? Probability is going to be reported as a decimal. Likelihood or chance is going to be reported as a percent. Good.